Okay, guys, we're back here with 5G 4, and we're now looking at our ed puzzle here. And when we're looking at our ed puzzle, we need to be able to use our notes here in order to be able to answer some of these questions. So that was the whole point of taking those notes. So what we're going to look at right here is our shapes and our things. And the first thing I want to do is go over what acute. You should know acute means anything less than 90 degrees, right? Obtuse is greater than 90. Not 190, just 90. Parallel means they'll never touch, and perpendicular means they intersect. So let's look at this one. Oh, and they intersect at a 90-degree angle. We can't forget that because then they would be perpendicular. They would just be intersecting lines. If you look at this triangle right here, and we know that if I were to get out a protractor and measure these like you did in 4th grade, that this triangle right here, is it going to include any acute angles? Well, all of them are acute. So yes, all of them would be acute. Does it have any obtuse angles? No. Does it have any parallel lines? No. Does it have any perpendicular lines? No, because none of them will meet at a 90-degree angle. That's less than 90 degrees. Okay? So let's look at this one. Let's see. What I like to do is I like to draw all of my angles in. And what do you notice about all of these angles? Do they have any acute angles? Do they obtain any obtuse angles? Yep, they have obtuse. They do not have acute. Does it have any parallel lines? Yes, this line right here is parallel to this line. So that's one. This line is parallel to this line. This line right here is parallel to this line. So what you'll notice is you're like, why do I have all those slashes? Because this slash right here tells me that it's the same as this one. This one right here tells me it's the same as this one. And this one right here tells me it's the same as this one. So yes, they do contain parallel lines. Do they have any intersecting lines or perpendicular lines? So is anything interacting at a 90-degree angle? Okay. Let's look at this question right here, or look at this shape right here. Any acute angles? Look at your angles here. Any obtuse angles? Any parallel lines? Any perpendicular lines? Okay? Looking at the middle question right here, is the statement below true or false? Explain your answers using words. A parallelogram is always a square. Well, here's the thing. Remember our diagram here. Parallelogram, square. A parallelogram is always a square. Always, meaning there's no other options. No, because a parallelogram could be a rhombus. It could be a rectangle, right? So we're going to write no. A parallelogram could also be a rhombus or a rectangle. However, a parallelogram cannot always be a square. However, what about a square? This will be on your AOG. A square is always a parallelogram. And we're going to look at this map over here, and we're going to go through this. So no, a parallelogram is not always a square. because it can be a rectangle or a rhombus. Okay. However, look at our square. And if I say a square can always be a parallelogram, a square is a parallelogram. It has to have two parallel sides. That's the only definition that works with a parallelogram. So if a square has two parallel sides, it's definitely going to be a parallelogram. But however, a parallelogram cannot always be a square because it can be two other things. So when you're looking at these things, if it's moving up, if I start at the bottom and move up, it can always happen. But if I'm starting at the top and I'm moving down, it can be alternate things. So you got to be careful because a quadrilateral cannot always just be a square, but a square can always be a quadrilateral. A trapezoid can always be a quadrilateral, but a quadrilateral cannot always be a trapezoid. Okay? So you need to make sure that when you're looking at this and you're looking at it backwards, think about what is being asked. A square can always be a quadrilateral. A square can always be a parallelogram, but a parallelogram cannot always be a square because it can be two other things. So that's why this is so important and when we're talking about our polygons and doing our hierarchy here, because this will help you determine whether those statements are true or false. Okay? Now it says over here, complete the chart below to show the relationship between polygons. Now, we've already made our chart, right? So I have to use rectangle, quadrilateral, parallelogram, and square. Well, polygon is going to be a what? If I look at my map, polygons go to a quadrilateral. So your very first thing is going to be quadrilateral. Okay? After quadrilateral, I'm going to have a, type it in. After that one, it's going to lead you to a, type it in. And my very last box in this one should be a, yes, please type that into Edpuzzle. Okay? Looking at this one right here, we're going to classify our triangles based on their length and their sides and their angles. So that's why it can have more than one name. The clue is 0 congruent sides. Congruent means the same. So if none of the sides are the same, do you remember when I said over here, if none of those sides are the same, look at the picture over here. If none of them are the same, meaning they have 3 different hashes, what type of triangle is it going to be? I spelled it wrong on this thing, but that's okay. Type in it over here. So what you should look like, your picture, I'm sorry, I gotta draw it the right way. And when I draw my picture, type in the name that it is. Okay? 2 congruent sides, meaning that 2 of the sides are the same. This side and this side will be the same. And go over here and look at your thing and what's another name for that triangle. Make sure you type it into Edpuzzle. And then the very last one, 3 congruent sides. 3 congruent sides means all the sides are the exact same length. And when all of the same sides are the exact same length, there's going to be a name for it. So look over here. Make sure you write it down here on here and type it into Edpuzzle.